Hey, what's up everyone? So in this video, what I'm going to do is I'm going to show the different methods of valve spring compression tools and their uses and what type of cylinder heads they're going to work on, as well as some tricks that I found to getting the keepers to stay installed during that process. And we're going to go look at a couple different style cylinder head designs and what tools are going to correlate with each design. So we have a single overhead cam Nissan cylinder head, which is going to have the valves kind of canted away from the camshaft. There's a lot of clearance. Also have a Wedge design cylinder head off a 6-liter LS, and then a Subaru cylinder head that is a bucket style cylinder head where it's going to have a shim bucket that goes above the valve once everything's installed and has the cam right over it, and it makes it kind of difficult to get the springs, keepers, and retainers all in this tight bore that bucket's going to ride on. We'll show all the different types of tools that I have kicking around the shop and their different methods to do so. When you are rebuilding a cylinder head though, you want to make sure that everything is organized. This is all the valve components for this Nissan cylinder head. Everything's been cleaned, checked, and measured, and it's ready for final assembly. The first thing that we normally do on final assembly is we want to make sure that we install the new valve stem seals. However, on this designed engine, and I discovered this, is that both the exhaust and the intake are dual spring, and they also have dual shims to go along with this. Now these shims are going to do a couple different things, but the thing that's really important for us during installation is that this hardened spring can dig into the aluminum face where the spring rides, and that can cause premature wear. It can allow for it to dig in and create some issues. So we need to make sure that we install the shims. Now I discovered that with the valve stem seal installed, you cannot get this inner shim on. So it is important in this application to make sure that we're installing the inside shims first to make sure that we are able to get everything put back together the way that it should be. So let's take a look at some of the tools that we might be using. All right, so let's take a look at the couple different type design valve spring compression tools you can have out there. So these are all the ones that I was able to find kicking around our shop. And we have a couple mechanical ones as well as a pneumatic one. We also have a larger in-place stand one. This one will be used for that bucket design cylinder head that Subaru uses. But we do have a couple different type reach, couple different type designs in terms of how close they can reach in, how close they can't, and whether or not they can be used for larger or smaller springs. This is the one that I personally use quite a bit. I found that it does have a little bit of a limited throw, and it's meant for overhead cam design engines, but I have been able to make it work on some overhead valve engines or push rod engines. But this is one that we're conventionally using for that design, which it's going to be a pull design. The pneumatic one is, these two are effectively the same, except for this one's using your hand strength. This one you have you're setting it up with an airline, and you're having an on and off control to press this down. These can be a tad bit scary, so you do need to use them with a little bit of caution, because when it goes, it goes. There's no metering it. The same can be had with this. It's just this one, once it goes, it's going. This is an adjustable sized one, kind of very similar to this one, where we have the ability to adjust how much of a throw we have. This is also an adjustable arm that can be changed out depending on how big the valve spring is. Same thing with this one. We have the option for 2 different valve spring sizes to go along with this one, as well as we can change the height on either end. I like this one the best because it's kind of customizable on what you might need on multiple type of situations. We also have 2 different design of in-car valve spring compressors. This one is designed for a multitude of different applications that Chrysler offers. This is a special tool that gives a couple different options, and effectively you're going to bolt this to the top of a cylinder head with the valve cover off, and using compressed air and the cylinder at top dead center, you will compress the valve spring to change out the valve springs in the car, or doing an in-frame repair. That way, if you need to change a valve stem, or if a valve spring breaks, you can change it out without taking the cylinder head off. This guy's doing the same thing, although it's a little bit not as stable, and it can be a little bit cumbersome. The hot trick with these is to put a hose clamp around them so that they don't splay out. And again, we're going to use this larger bench-mounted jig that we have on a cart for our bucket design cylinder heads. So let's take a look at our first design. So we'll grab this guy and show the benefits to installing valve springs and compressing these on our Nissan cylinder. So first and foremost, we do need to install our valve stem seals. Now these valve stem seals just have a little bit of a tight interference fit between the seal and the valve guide. There's a couple different ways you can install these. The first method is with a dedicated valve stem seal installation tool. Now these come in a bunch of different sizes, and effectively the valve stem seal sits right inside of it, and you're able to lightly press down on this to install the seal. I've also been able to use a socket that contacts just the metal base of this. You don't want to compress on the rubber portion or where that garter spring is. You want it to just barely touch the metal portion, and you want it to kind of spin a little free. If you move it, there's very little resistance on this valve stem seal against the socket, and that works as well. You just need to make sure that you're not pushing these down too far. They are very, very fragile, and they can splay out, and that will cause a leak later down in the future. So you go through and install all new valve stem seals at this point with the shims in place, and then we can move forward with compressing the valve springs and getting the keepers to stay in the retainers. So in this case, we'll start with this exhaust valve. So we have the valve in place with the two shims. The valve stem seal is already installed, and we're going to install our spring pack. So we have two springs in this case with our spring retainer. And the first of the valve spring compressor tools that we're going to use is we're going to use this beam style one. Now, a couple of things to go along with this is the two ends are fixed. So we have a smaller end and we have a larger end. So you want to get the largest end that's going to fit on the valve spring retainer. In this case, that is our bigger one. You can't manipulate these at all in terms of size where you can on the other machine. We have this locked down, so I've gone through and made sure that the height of this portion of the tool versus the height of that portion of the tool will allow us to compress the spring down to where we can get to the ridges on the valves to get the keepers in. What we're ultimately doing is we're compressing these valve springs down to where we can expose this groove that's cut in the valve so that we can get this keeper or two keepers to wedge in and prevent that retainer from popping out. So we're going to have two of these. It's a little difficult to do with only one hand. So we're going to have two of these keepers holding that retainer, and that will keep the spring in place. So we need to try to get the spring compressed enough to access to where we can get that groove exposed and we can get these keepers in place. So that requires us to turn the adjustment knobs on the tool to make sure that that works. Now, this tool does have a really small throw in terms of actually compressing the spring, and it can be a little bit difficult to do that if we're dealing with springs that take a lot of pressure to compress. So what you can do is you can set this end a little bit loose, compress down and lock the tool in place. So when this handle goes down and locks, it will prevent the spring from coming up. And then you can use this little hand knob to turn and compress the spring the rest of the way to be able to get the groove exposed. And that's one of the reasons why I do like this tool, is you have a couple ways to get it compressed if you're tight for space or if you're dealing with a very tight valve spring. This end is going to go against our valve. We need to make sure that it's as centered as possible. If it's off kilter at all, or it is able to spring loose, and this a lot of times isn't big enough to fit around our retainer right there. So this is a little bit loose fitting on this particular cylinder head because it's not the exact application for it, but we'll show, I'll still show, demonstrate how it's going to function and work. So I have the cylinder head elevated off of the workbench on a set of cylinder head skewers or pin plate or pins. You can use, and we're going to have to use the other tool, a set of Ys that support the cylinder head. The key thing is we don't want the cylinder head resting on any of the gasket surfaces, especially the head mating surface, which is down here. That would, cause likely for a blown head gasket a lot easier than it normally would. So we want to make sure that that's clear. If you can, you work on a block of wood. Modern cylinder heads, especially cylinder heads that are cam in head, can be very awkwardly shaped. So it does take a little bit to figure out what's going to be a comfortable fit for the cylinder head staying put and not wanting to kind of fling everywhere. So got the spring pack in place. What we'll do now is we will install the compression tool. So we're going to center the lower end against the center of the valve, and I'm going to center this spring compressor cup on the retainer and then lower down on the lever, and that lever then clicks in place and this locks it. So now that this is locked down, it will allow me to fiddle around with getting the keepers in place. It is important. This cylinder head has a lot of clearance around it, so it's not too crucial on where this is positioned or where the supports for this retainer or spring compressor are located. But you may be in a situation where there's a pedestal tower or for the cam to be located or something in the way that you might want to make sure that these are turned, making it a little bit easier to get the valve keepers in place. All right, so at this point we're compressed down to where that groove is exposed and I can get the keepers to go in place. I do find that in this situation you do have enough room to get your hand in place and put the keeper in, but a lot of times they'll want to drop down or be a little bit difficult to get in place. So what I do is I magnetize the end of a small flat blade screwdriver, and I have a couple of these flat blade screwdrivers that I use specifically for this, but basically it just needs to be small enough to lightly grip the keeper and prevent it from falling out or falling off. And the way that you can magnetize these is you can take an old magnet, a lot of times from a speaker is a good option, and you just kind of wave the blade around the magnet, and that will temporarily magnetize the end of this screwdriver, allowing you to be able to keep the keeper in place. The other thing that I find that helps quite a bit is to use either installation lube, or my preference is white lithium grease, and you just apply a small amount of light white lithium grease on the inside of this keeper. And what that's going to do is that's going to allow this keeper to kind of stick to the valve stem. So if I come around and place it, because this is just lightly magnetized, having the white lithium grease will stick to that valve stem. And so we can see the keeper is now stuck to the valve stem right there. We'll then get its corresponding keeper to go in place. Again, with a little bit of white lithium grease. Get it placed with the screwdriver and with my finger. At this point, we want to make sure that both of the keepers are gripping that valve stem, so that when we release the tension off of this spring, they won't fling out. It's very, very important to make sure that you're wearing safety glasses at this point, because when we release the spring tension, if those aren't in place, they can ricochet out. So I'll just release the spring tension. And from there we have our valve spring compressed and retained with the retainer and our clips. And that's all that we need to do to have that be completely installed. The little bit of white lithium grease isn't gonna hurt nothing. On a new motor or a motor that's getting just the cylinder head repaired or replaced or serviced, it's a good idea to flush the engine oil after it's run for a little bit. The white lithium grease isn't going to hurt anything in the oil. It'll be just fine. And you can wipe off any of the excess, and that's all nicely retained. So we'll do another one with the other tool to kind of show the benefits to it. All right, so the other one we're going to utilize is this little wider swing valve spring compression tool. I'm sure each individual tool that I'm using has its own individual name. Forgive me for not knowing. I don't know the names of them. However, I do know that, you know, we're going to be doing the same function. So with this tool, we're going to be setting our height that's going to be going against our valve via this threaded collar, and that'll thread in and out. And this will allow us to, we do have a locking collar that allows us to compress the spring down. That will lock in place. If we need to go a little bit further, we can turn this. So this is kind of similar to that other tool we were just using. Unlike the other tool, however, though, we have our retainer end right here. Now this has a little tiny set screw, and what that screw is going to do is we loosen up the nut that's right there, and then we actually thread in the bolt, and there's a threaded end on this end of the arm, and that will expand or contract this little jaw to allow us to fit the retainer in. And the idea is we want kind of a snug fit with the retainer in this tool. What that'll do is that will prevent it from slipping and want to come out during compression. So this is a little bit nicer than that other one in the sense that the other one was not really sized for the retainers on this particular cylinder head. So this one, we do have the ability to do that, to size that, and these can go quite a bit. You can see there's still quite a bit of thread left, and we're just going to undo that lock nut and then move the nut in, or move the bolt in and out, and then lock that down with the lock nut so this doesn't, you know, expand or contract while we're using the tool. All right, and so with this tool, just like our other one, we're going to do the threaded end. That's going to be centered on the valve, and we're going to have the retaining lock end in. So I'm lining everything up, making sure to check everything, and then I'm pulling the pull lever. And when the pull lever clicks like that, we're now locked in place, and we can now work with getting the keepers in on the retainer. Now, what I find with these ones is because these ones are kind of thin right here, you can see where it kind of arcs over a little bit, and it bends, and we don't have, you know, kind of a square shot to get the keepers in. However, we have way better access to getting them in. We don't have the cage going around it to where, you know, we have to kind of fumble around with that. So you can do it with your fingers if need be. I still like to use the screwdriver just to make it a little bit easier. So what we'll do with this one is we'll do the same thing. We're gonna take our keepers, add a little bit of white lithium grease to them to have them stick, and place them around the valve stem. Now you can do this again with your hand. I've seen a lot of people where they hold it like this. I haven't been pinched before, but the fear of getting the end of my fingers pinched is great enough to where I just use a little bit of white lithium grease and the screwdriver, and that's fine. I don't really have a want or need to squeeze those together. So at this point, again, we're gonna look at the same thing, that our two keepers are against the valve stem. We can then release the lever to allow that to come up. And again, we've now have the retainer retaining the spring under load, the valves installed, everything is as it needs to be. So for our last one is I'm gonna show the pneumatic style tool. All right, now with the pneumatic tool, we have a lot of the same features as the last one we were looking at. This is able to thread in and out so that we can get the right height, as well as we can turn this lock nut in to expand or contract the retainer grip there. I have this set up. It is one of those things that when you do set this up, you want to thread the valve face part of the tool to where there's really no space. It will have a pretty big throw on the tool, so you do kind of need to judge off of what's going to work best. But I like to have it to where it's just, you know, putting a little bit of pressure on the spring. That way the tool doesn't, you know, jump or anywhere, or you run the risk of if the retainer isn't beginning in the valve stem, it could bend the end of the valve. This thing's really pretty powerful. So you do kind of need to be cognizant of that to where you're not going to be bending the end of the valve. So I have it to where there's a little bit of tension on the valve spring itself to where the end of the stem is in the retainer like that. So it's kind of locked in and it's not going to go anywhere. From that point, we're then going to hit the trigger, and it's that outer button on the two controls. So this one's going to be compressed, that one's going to be released, and we now have the valve stem retaining lock groove exposed, so we can then get our keepers and put those in place. I also did have to, just to note, I did have to mount the cylinder head on a different method. The skewers weren't high enough for the pneumatic tool to get in and actually compress these. So we have this set up to where it's compressed. We have both our retainers in, so now we can release it, and that is going off of this button right there. So if I press that, we then now come up and our valve is retained by the retainer that's holding the spring down, and the two clips are in place, and that's all that's to it. The nice thing with the pneumatic tool is you can go real fast with it. You can, especially tearing down cylinder heads. This thing's great for tearing cylinder heads down. You can have a cylinder head yard sailed on the bench real fast with one of these. Downside is you do have to have an air compressor with it, and they can be a little bit scary to get used to at first, but they are a very good tool. So at this point, I'll do the other two valves, and then I'll kind of show you the bucket design. All right, so the last off-car tool that we have to use is this bench-mounted spring compressor tool. Now, the idea with this one is to get in nice and deep to be able to get these bucket-style valve spring retainers in and out. Now, this is designed, the engine's designed to have this shim bucket that rides on top of the valve, and the cam would go this way. So this is recessed into a bore that shim cup goes into, so we have to kind of work around that. So this tool allows us to be able to have enough clearance to get onto the keepers, as well as it has the ability to stay real stable. Now, this is a little bit worn out of a machine, so kind of got to bear with me on its operation. But what I have is we've set up the base plate that this the cylinder head rides on. Now this has the ability to angle it up or down. We want to make sure that these are locked in and they're even both left and right. We also need to set the cylinder head depth. And the way we do that is with these little pins. Now my pins happen to be little 10mm oil pan bolts that I found, because we don't have, the pins have been missing for a very long time for this. So we have that depth set, and then we also have the arm position locked, and that's what this little quick release is for here. This allows us to be able to release that, lift up on the head, and then slide it to the different valves that we're doing. We need to make sure when we are sitting or getting the cylinder head in place on one of these jigs that we do have enough clearance for the bottom arm down there, which is right there, to come in contact with the valve and not come in contact with these base plate arms. I've found if you don't get it kind of just right, especially on a small cylinder head like this Subaru head, we can get into an issue. Now this head's got to get cleaned and serviced, so this is just for demo purposes. So with this, I have the arm set in place, so I'll hit the locking tab up, and then I can pull down on this lever, and that allows me to gain access to the retaining ring groove. Now unfortunately, this tool is worn out to where it doesn't lock down. The lock mechanism is worn out, so I'm going to have to hold tension on it. So I have a keeper pre-greased up and on the screwdriver, so I will set the first keeper in place. This tool has a fair amount of clearance to where we can get these keepers in against the valve stem and lock. And that looks to be locked, and we'll get the other one set on the screwdriver. So we'll get the other one, put it around the valve stem as well, making sure that both are in place and not going to come loose. and then we can release the tool. And then from there, went down to make sure that our keepers are in place. And from this point, then we'd release our lock. We'd slide the head down, or the tool down to the next valve to then compress that one. And then we do this side, flip it around, and you do the same thing. So nice and easy. The nice thing with this one is everything's super stable. So the other ones, you know, I was on the skewers for the one set of cylinder heads, and that worked really pretty well, but you know, they can still flop around. This is super stable. It stays put, and you can work with it really well. I got to work out fixing the lock mechanism. Kind of been lazy and not doing that on this, just because of, you know, usually you can get someone to hold it for you while you make things work, you know, and that's no big deal. All right, last thing to show is just wedge style cylinder head design. So this is a push rod cylinder head off of a 6-liter LS truck motor. What we have is we have the valve spring and keeper in the head and our valve in the combustion chamber. Really pretty straightforward, just like the other cylinder heads. This cylinder head does need to be taken apart, so it's kind of giving you know, to show how that's gonna go. So same thing, we're gonna have our retainer against, or a retainer claw against the retainer, and we're going to place the compression against the valve tool, so that's going to hold the valve in place. I've locked it in here, and I'm able to have the tool in place to get the two keepers out. So I didn't quite get it the right depth. So what I will do is I will release this and get it to go down a little bit further. And then from this point, I can get access to either keeper. Oop. Release the tool. You want to release it slowly, and then that way we can now get the two valve springs, our valve spring retainer, and remove the valve from the cylinder head. And then we do the reverse order once everything is serviced on this particular cylinder head. So pretty straightforward. All of these different tools are usable depending on the application. It kind of is one of those things, if you're working on multiple different style engines, you kind of need a variety of these different valve spring compression tools. And just use some of these techniques. There's other techniques that you can definitely use to help you out on installing valves and so on and so forth. So other than that, I really appreciate you all taking the time to watch the video. I hope you found it helpful and somewhat entertaining, and I will hope to see you guys in the next one.